Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you about the second topic and very important topic, that is phases of compiler. Okay, so last video class I taught you language pre-processing system, and here we have some few phases. That means the compiler come across few phases. Okay, so if all the phases are executed, then only we will get a machine code. Okay, so low level language code, that is digital code or assembly code. Okay, so the phases of compiler, very important 13-mark question. The first phases is lexical analyzer. Okay, this is the first phases of compiler. You should understand what is the duty of lexical analyzer. Lexical analyzer is used to convert source program into tokens. I told you, you know what is meant by tokens, right? What is token? That is the big program converted or break into small pieces. That is called tokens. Okay, so when you see this example, position colon equal to initial plus rate star 60. This is a source program. Why I said a source program is position, it is an English word, rate initial, this is an English word. Okay, so ordinary high level language, that is a source program. So first step of lexical analyzer is it converts source program into tokens, that means small pieces. Clear? Okay, for example, you have to assume I am going to write one English level program, that is one C program, addition of two numbers, etc. So that is a source program. So what the internally compiler do is it converts the source program into tokens first. Okay, how it is converting is, for example, I told initial plus rate star 60, that is the line of the source program, and it converts position into ID1 identifier. So it machine understandable tokens. Position it convert into identifier. Equal to, that is comes and close brace, open brace, equal to. Okay, this is a token. This is one token. This is another token. Initially it's converted into ID2 and plus operator. ID3 is a identifier. Star is an operator. 60 is a number. Like this, it convert into tokens. So you have to understand the first step is source program is converted into tokens, that the duty of lexical analyzer. Okay, so what we will get is tokens, right? And the second one is syntax analyzer. Clear? Okay, what is the duty of syntax analyzer is the tokens is converted into parse tree. Okay, or syntax tree. We studied like trees, right? Node and child node, etc. So this syntax analyzer is converts tokens into parse tree. Okay, tree like structure. And what is the use of this tree like structure is sequential execution can be performed by using this tree. Okay, we will say parse tree. While parsing the program or scanning the program, this tree like structure is useful. Can you understand? Okay, so how it is converting the tree like structure is, see, this is the source code, ID1 equal to ID2 plus ID3 star 60, and equal to is an operator. Always we know the root node should be an operator, right? That we studied in data structure or something. Okay, equal to is an operator, and then left child of operator is ID1, this is the child node, and plus is an operator, and left one is ID2, right one is star is an operator, and ID3 is left side, 60 is right side. Can you understand? Once again, see, this is the tokens, and always in parse tree, root node is an operator. So equal to comes as an operator, and left side is ID1, and then plus, and then left side is ID2, and star left side is ID3 and 60. Okay, what is the use of this parse tree? See, sequential execution. Compiler knows how execute. For example, first it execute ID3, one value is multiplied with 60, number 60. Okay, so the answer of this is added with another one value. Okay, and this every answer is assigned in ID2, that is equal to this assignment operator assigned in ID1. So answer, all the answers should be present in ID1. Okay, can you get it? So why this syntax tree is important? Okay, so in order to execute properly, the syntax tree is important. So to convert tokens into syntax tree, the duty of syntax analyzer performs. Okay, and the third one is semantic analyzer. Semantic analyzer. Semantic analyzer. Right? Okay, once syntax tree or syntax analyzer is performed, next step is semantic analyzer. So see, the same tree like structure is repeated, right? So the output of semantic analyzer is also the tree structure, that is parse tree, but it performs some operators that for example type checking. It performs some operators type checking. See, in this program or in this lines of code, 60 is a constant number, but compiler doesn't know 60 is a integer or real or float, etc. So in this phase, semantic analyzer phase, this 60 is a number is converted into, normally it converted into real or factorial. Okay, normally the compiler, some default compiler, it converts integer into real, always it converts into real numbers. Okay, so the conversion is performed here. For example, I have given, I want to add 60 plus 60. I want to add 60 plus 60, but compiler doesn't know 60 is the number, I know, we know, but compiler doesn't know it is integer number or real number or float number or decimal number. Compiler doesn't know. So here it assign or it checks the type, whether 60 is integer or whether 60 is character or 60 is a number or 60 is a real value or float value, etc. It should be performed in semantic analyzer. Simply semantic analyzer is used to type checking. Okay, used for type checking, that is the very important. Okay, next one is intermediate code generator. Intermediate code generator. Right? So this three phases, after performing these three phases, we know the tree structure is we obtained after semantic analyzer, right? Okay, so the input of intermediate code generator is parse tree, right? Tree. If you see this phases, the input is tree, and the output of intermediate code generator is intermediate code, relocatable machine code. Okay, see, for example, this is the semantic analyzer phase, and now this is the intermediate code phase, Okay, normally in real time compiler, for example in Windows or Windows operating system or some licensed operating system, we cannot see the intermediate codes, but open source operating system, Linux or Ubuntu, there we can compile, we can see the intermediate code. Okay, this operation is performed internally. The operating system does the intermediate code generation, but we cannot see in a licensed version, but open source we can see this intermediate code. But we cannot understand some intermediate codes because it may be in symbol equal to question mark, like that we cannot understand, but computer can understand. The duty of converting the parse tree into intermediate code is intermediate code generator phase. Okay, this phase is very important phase in a compiler design. So this is the computer or operating system does this job, right? Compiler does this job. T1 equal to int to real of 60. I will explain you. This is the parse tree we will obtain, right? Parse tree we will obtain. Now the intermediate code is from the parse tree it convert into intermediate code, because this step says like that, right? Semantic analyzer phase, after semantic analyzer phase only intermediate code generation phase. From here it convert taking the input as a parse tree, right? See, 60 is multiplied with ID3, and first this 60 is converted into real value or float value, etc. That based on the compiler it converts. Int to real of 60, integer is converted into the default type. That is in this compiler int to real of 60, and that is stored in T1, temporary value, temporary memory. T1, T2, T3, this is the intermediate code phases that we will study in the 4th unit. Okay, right. T1 intermediate memory, temporary memory 1, temporary memory 2, temporary memory 3, etc. So into to real of 60, it's convert integer value into real value, then it is stored in one temporary memory, that is T1. Clear? So this temporary is stored in a memory. And ID3 star 1, see this ID3, this star, and here temporary memory 1, this answer is placed. So ID3 star T1, it is placed in another temporary memory, that is T2. Clear? Okay, now this is executed, this is okay. Now this answer that is present in T2 is added with another one, ID2. So T3 equal to ID2 plus T2. Clear? And now this is T3, this everything is T3, and it is assigned in ID1 equal to T3. Okay, like this, this is the temporary code, that means intermediate code. Intermediate code is source code, machine code, intermediately we have one code, that is the intermediate code that we cannot see, that compiler will perform this intermediate code based on the parse tree, Clear? Okay, now next phase is code optimizer. Code optimization. Okay, so this is one of the optional phase, because but this phase is very important. Why is code optimization phases reduce the amount of code without affecting output. Here see 1, 2, 3, 4 lines of code is there, I will get one answer, but after performing code optimization the same answer I will get, but I can reduce the number of codes. I am using 3 memories, temporary memories, T1, T2, T3. 3 memories I am using, but after optimization we can reduce the code without affecting the output. For example, see T1 equal to ID3 star 60, okay, 60.0. See here into to real of 60, I converted into to real of 60 and assigned in T1, but directly what I am doing is real number I have given, that is 60.0. Okay, now this real number is multiplied with ID3 and is stored in T1. Okay, so this 2 lines of code I have executed in a single lines of code. Similarly, see ID2 plus T2 and ID1 equal to T3, this 2 lines of code I have executed in ID1 equal to ID2 plus T1. Okay, so this is the code optimization phase, that is we can optimize the code, okay, we can reduce the code. So 4 lines of code I have reduced into 2 lines of code, right. So next phase is code generator. So what is the use of code generator phases? It is used to convert intermediate code into assembly code, mnemonics code. Okay, we know, we studied this assembly code in microprocessor subject, we studied this assembly code, add, multiply or subtract, etc. Okay, so how it is converting is, see into to real of 60, that is the number, okay, the given number value, and ID3 is a value, that is variables that programmer have given, ID3. Okay, so value should be moved into register. You remember, this is the concept in microprocessor, value should be moved in register. If you want to add or multiply the number directly, we have to give immediate value, that is hash symbol we have to give. Okay, see this the thing of this one node is ID3, the value should be multiplied with 60. So see, before that ID3 is a value, so we have to move into register. That's what load R2, ID3. R2 is a register, so ID3 is moved into register 2. You can give R1, R4, etc. But R2 is a register, ID3 is moved into R2. Then I can multiply with 60 immediate value. So multiply R2 with 60 immediately. Okay, that's what I given hash. If I didn't give immediate value, you can again load 60 into one register and you can add with that register with this register. Clear? Okay, now straight away I can multiply it with this register with the number 60 and it is stored in R2. Okay, now see, this is the ID2, I want to add it with this one. So what I do is ID2 should be loaded into one register. So load ID2 in R1, then I have add. So add that register with R1 and its answer is placed in R1. Clear? Okay. Now assign, that is here we have on all the answer I am going to assign with the ID1. So store ID1 comma R2. ID1 comma R2. This is the assembly language code. Okay. So this is the way the compiler produce source code into assembly language code or machine code. Okay. So this is the structure of the program. Another two important phases there. One is symbol table and another one is error handler. What is the duty of symbol table is, if you give int a, the a is a variable which is stored in a symbol table. Okay, a is a variable which is stored in a symbol table. Whenever the program needs that variable value, it takes from the symbol table. So symbol table is a data structure which is used to store and retrieve the value. Okay, and error handler is a phase. In all the phases error may occur. We have this much of phase. In all the phases error may occur. So whenever error occurs, it handles the error. For example, int is a keyword. For unfortunately, the programmer may give in, okay, instead of int. So this is the error. This error is handled by the syntax analyzer and it gives to the error handler. This error handler displayed to the user. That's what in all the programming language many errors may have. Okay. So that error phases I will explain you in the next class. Okay. The error I will explain you in the next class. So this is the phases of the compiler. Okay. Next class I will teach you the errors, what are the errors occur in the phases of the compiler. Thank you.